Now, till now what we have discussed, now first let us see, let us review and then move on to another module, namely inequalities in science. But let us first review what we have done till now. If you slightly recall, we started with the very thematic preliminaries concerning science, technology and society, the way these three forces of production, namely science, technology and society, have evolved over time and across space, and then we moved on to forge the relationship between science and technology on the one hand and science, technology and society on the other. Okay? I mean, we started with the ontological questions, and then from there we moved on to a discussion on how STS, science, technology and society, is a discipline, is a subdiscipline which is a byproduct of a conglomeration of three important disciplines, namely philosophy of science, history of science and sociology of science. Okay? And then we tried to discuss epistemology as a body or theory of knowledge. Why is epistemology considered a body or theory of knowledge? Precisely because the kind of central philosophical political questions that epistemology addresses. That is, what is knowledge, how is knowledge produced, how is knowledge generated. Okay? But the scholars of epistemology ignored for a pretty long period of time the question of ethics, and then we see the demarcation between natural philosophy and moral philosophy. Okay? I mean, what is ethics? Ethics is a study of nature of conduct, okay, as we have already discussed. Why is it so? Why is ethics called a study of nature of conduct? Precisely because of the central philosophical political questions which ethics addresses. They are, what is good, what is bad, what is right, what is wrong and so on. And if you combine epistemology with ethics, we get philosophy of science. Okay? That is why it is very important for STS scholars to look at not simply epistemological questions, but also ethical considerations. Okay? Then from those ontological questions, we moved on to a more normative structure of science propounded by Robert Merton. There we discussed ethos of science, I mean institutional imperatives of science. What do you mean by ethos of science? By ethos of science we mean effectively toned complex of values and norms which is held to be binding on the man of science. And these norms are expressed in terms of prescriptions, proscriptions, preferences and permissions. When I say prescriptions, it is a broad normative framework. Proscriptions are those norms which are legally bound. Preferences come under the rubric of motivational norms, values and ideals, whereas permissions come under the framework of institutional mandates, institutional values, institutional norms and institutional ideals. Okay, in this sense, Merton used these terms, these concepts. Then we discussed the goal of science as the extension of certified knowledge. Then we discussed the imperatives of science which are derived from the goal of science, and also the kind of methods which science deploys. Okay? When Merton said methods, technical methods, I mean empirically confirmed and logically consistent statements of regularities. Okay? And then Merton went on to flag 4 institutional imperatives, 4 ethos of modern science. They are universalism, communism, disinterestedness and organized skepticism. Whereas universalism, communism and disinterestedness come under the broader rubric of Mertonian goal of science, organized skepticism comes not simply under Mertonian goal of science, but also Mertonian technical methods of science, that empirically confirmed and logically consistent statements of regularities. That is why organized skepticism refers to the fact that we must keep on postponing our judgment, we must keep on temporarily suspending our judgment unless and until all facts are at hand. Okay. From the ontological questions, we moved on to the normative structure of science. From the normative structure of science, we came to methods of science, and from methods of science, we will come to inequalities in science. Okay. Then in methods of science, what we have discussed? We started with the famous Aristotelian question that what is the method of science? Okay. The question what is the method of science is as old as science itself. I mean, how do we produce knowledge becomes central to the existence of science itself, becomes an integral part of the existence of knowledge itself. Okay. Till till in the 17th century, we came across a term called modern philosophy of science. I mean, the birth we witnessed the emergence of modern philosophy of science. From 17th century till 20th century, okay, we witness two rival methodologies, which suggested that there are two methods or there are two ways to produce knowledge. Okay. I mean, if you slightly recall, we have already discussed, science is a term which was coined by Whewell in the 19th century. Earlier science was known as natural philosophy. Okay. That is why we discussed how moral philosophy was branched out from natural philosophy in the form of ethics. Okay. That is one. Now, if you look at these two rival methodologies in the form of inductivism and hypothesism, which dominated the center stage from the 17th century till 19th century, 3 centuries taken together. Okay. For the proponents of objectivism, for the proponents of inductivism, okay, science starts with observations, remains at the level of observations and ends with observations. I mean, observation is the source of knowledge production. Then what were the steps that we discussed in inductivism? No, that in the inductivist schema, science must start with observation without recourse to any theory, okay? And from that observational data, without recourse to any theory, we come to the second step, that is tentative generalization, which requires verification. And then we come to conclusion. Hypothesism suggests that no, science does not start with observation, rather science starts only when we go beyond observations, because whatever observation that we make, observations are not presuppositionless. Observations always involve certain amount of selection, and selection is based on cultural relevance. Okay? From here onward, if we look at this discourse on these two rival methodologies, okay, from 17th century till 19th centuries, what we find in the 20th century, the emergence of a dominant school of thought so far as the question what is the method of science is concerned. Okay? I mean, that is positivism. That is why when inductivists argued that science starts with observations. Hypothesists argued, no, science does not start with observation, science begins only when we go beyond observations. Science starts with a hypothesis, which is a tentative solution to a problem or hunch. Okay? In this case, if science starts with a hypothesis, which is a tentative solution to a problem or hunch, then that tentative solution to a problem or hunch must be subject to some tests. If a hypothesis is tested wrong, then it must be rejected, and if a hypothesis is tested right, then it must be accepted in the hypothesis scheme. Right? And in positivism, as we have already discussed, how positivism emerged. Positivism emerged in a social, economic, political, cultural context, institutional context, ideological context, whereby we see the transition of different layers of society. I mean, transition in the development of society. Society was conceptualized in the form of metaphysics, initially theology, then metaphysics, and then positivism. What are those things? I mean, we have already discussed this, that the theological stage, okay, tried to examine changes in terms of supernatural forces, the otherworldly forces. The proponents of metaphysics tried to examine changes in terms of only natural forces, but of course not supernatural forces, only natural forces. Okay? That is why they say, the proponents of metaphysics used to say that only nature mediates our changes, only interventions can be made only through nature. Okay? Whereas positivistic stage suggests that no, it is not supernatural forces, or not, they are not simply natural forces, but human action determines what kind of changes that we have today, or we are going to have tomorrow. Okay? Then we have discussed the central tenets of positivism. To give you a few examples, what we have discussed, that science is distinct from all areas of human activity or creativity, because science possesses a method unique to it, that is methodological, that there is only one method common to all sciences irrespective of their subject matter, that is methodological monism, that the method of science is the method of induction, that the hallmark of science consists in the fact that all scientific statements must be systematically verifiable, that is systematic verifiability. There must be a dichotomy between fact and value. Facts are value neutral, whereas values do not have any factual content. Okay? There must be a unilinear relationship between observation and theory. Observation leads to the formulation of theory, but the converse is not true. Theory does not lead to observation in the positivistic schema. Okay? Then what are the steps that we have followed in positivism? It must start with, science must start with observation, followed by a set of laws, then a set of statements describing initial conditions, and the explanation that we are going to make, or the conclusion that we are going to derive from these premises, that a statement, okay, describing the phenomenon to be explained, okay, explains. As critics to positivism suggest that no, as we have already discussed, no observation is presuppositionless in the hypothesis schema. Critics of positivism suggested that, you see, whatever observations that you make, observations do not have any language or idiom for expression. Theory provides us with a language or an idiom of expression. Observations are not presuppositionless, observations always involve certain amount of selection. Selection is based on cultural relevance. Whatever observations that we make they must be adequate. What kind of adequacy you want to arrive at? Adequacy can be judged in terms of statistical generalizations also, and also at the level of meaning generation. Okay. This is what we have discussed, and such positivistic construal of science was systematically attacked by Popper, for whom what is the central question of philosophy? For Popper, the central question of philosophy lies in the problem of cosmology. What is that problem of cosmology? Now, the problem of cosmology is the problem of understanding the world, including ourselves as part of the world. Okay? If we dissociate ourselves from this world, then we are not going to understand this world. Then he goes on to discuss context of justification and does not say anything about context of discovery, because for Popper there is no I mean it is impossible, it is not possible to provide anything about context of discovery or provide a rational account or rational explanation of context of discovery, which Einar Hansen and others, they also brought about a critique to Popperian methodology. For Popper, what should be the steps to produce knowledge? What kind of steps science follows to produce knowledge? Now, for Popper, science must start with identifying a problem, a research question. Science must start with a question, a problem, and from that problem we must formulate a hypothesis. As we already know that hypothesis is a tentative solution to a problem or hunch, and as hypothesists argued earlier that a hypothesis requires to be tested, so also Popper said yes, it should be tested, but it should be tested through the process of systematic falsification. If positivists suggested that science can be cross checked, knowledge, the kind of knowledge that we produce can be cross checked, verified, I mean cross checked through systematic verifiability, Popper replaces systematic verifiability with systematic falsifiability. That is why a particular hypothesis must be systematically falsified, and the process of systematic falsification may result in the hypothesis being refuted. I mean a hypothesis may be tested wrong. If it is tested wrong, then it must be refuted. But if it is accepted, I mean if it is tested right, as hypothesists argued that it must be accepted, Popper deviated from this. Popper immediately said, no, we cannot accept this hypothesis, because under certain limiting conditions, under certain limiting circumstances, such hypothesis has been tested right, not under all conditions in the world. That is why a particular hypothesis, even if it is tested right under certain conditions, must be corroborated. Then systematic, I mean corroboration means you must keep your hypothesis permanently tentative. Okay? Then a hypothesis a hypothesis, when it goes through the process of systematic falsification, okay, is subject to refutation and corroboration in the Popperian scheme. From this, we have also discussed a critique to Popper. Then we moved on to Kuhn. Okay. For Kuhn, every science passes through two different distinct stages, namely pre-paradigmatic stage and paradigmatic stage. Natural sciences, namely astronomy, physics, chemistry and biology, okay, only they have till now entered the paradigmatic stage from pre-paradigmatic stage, because they have been, because these four disciplines have been able to build some consensus about their respective discipline. I mean, if pre-paradigmatic stage is characterized by divergent thinking, then paradigmatic stage is characterized by convergent thinking. If pre-paradigmatic stage is characterized by plurality of practices, then paradigmatic stage is characterized by uniformity of practice. Okay? That is why Kuhn suggested that creative areas like art, literature, music, dance forms, philosophy and even medicine, okay, perhaps they will not be able to reach the paradigmatic stage because of the inherent divergent thinking in these disciplines, because of the inherent plurality of practices implicit in these disciplines. Okay? And then he went on to say that no, astronomy was the first discipline to enter the paradigmatic stage, followed by physics, chemistry and biology. Okay? What is a paradigm? No, paradigm is a model. A paradigm is something, is the one which poses model questions, not only poses model questions, but also provides model answers to those model questions. Not only provides model answers to those model questions, but also provides the methods to arrive at those solutions. In other words, a paradigm is the one which poses model questions, tries to provide model answers to those model questions, and also attempts to show and demonstrate what are the ways, procedures and methods to solve that problem. Okay? In this sense, that is why perhaps social sciences can never reach that stage of, because of the nature of research questions, because of the nature of research problems in place. Now, then if you look at this, then what are the steps which Kuhn followed? Kuhn followed certain steps through which we look forward to the furtherance of knowledge production in science. Okay? What are those steps? For Kuhn, after pre-paradigmatic stage to the paradigmatic stage, within a certain paradigm, there is a normal scientific tradition. That is, when I say normal, I mean norm bound science, institutional framework bound science, okay? Rule bound science, regulation bound science. Okay? And while carrying, I mean normal science is a tradition bound activity, normal science is a puzzle solving activity, normal science refers to the day to day research activities that scientists are engaged in. And within normal science, we encounter certain anomalies. Anomalies refer to the unanticipated or unexpected occurrences or happenings. Okay? In this case, if when anomalies appear, when anomalies occur within normal scientific tradition, and we do not have adequate acumen, expertise within that existing paradigm to address those anomalies, then that paradigm itself will be crisis ridden. Okay? Then the scientific community of each discipline, of respective disciplines, they start looking for a new paradigm which can address such anomalies, which can address the problems of anomalies. And once they find out a new paradigm, then a new paradigm will replace the old paradigm or the existing paradigm. But from crisis to the new paradigm is mediated by revolutionary science or scientific revolution, what Kuhn suggested. Okay? In this case, if normal science is the tradition bound activity, then revolutionary science is the tradition shattering activity to the complements of the tradition bound activity of normal science. Okay? That is why it goes beyond the purview of normal science to address the problems of anomaly, right. Then when you look at this, having discussed this, we moved on to a comparison between Popper and Kuhn. We also discussed we made a comparison even between positivism, Popper and Kuhn. How if positivists suggested that it is through systematic verifiability that our science can be considered legitimate and valid. For Kuhn, for Popper, it is systematic falsifiability. For Kuhn, it is not simply through systematic verifiability or systematic falsifiability, but consensus. Okay? That is why I gave you the example that whether India should go ahead with nuclear tests or not, is it a scientific question or a political question? It is the consensus through which we make these decisions. Okay? But what is the similarity among inductivists, hypothesists, positivists, Popper and Kuhn? All these traditional philosophers of science, they have always placed science on a higher pedestal vis-a-vis non-science. For them, science is supreme, science is unique. Okay? There must be a demarcation between science and non-science. And such kind of demarcation, autonomy and cognitive authority of science have always led the traditional philosophers of science to make a distinction between science and non-science. Therein lies the significance of Paul Feyerabend's interventions. The kind of interventions that he made, okay, he has become a legend in his own lifetime. Okay. Feyerabend wrote Against Method. Okay. He said that what traditional philosophers of science have been doing, they have been trying to look at the question, what is the method of science? Is there a method of science? Can there be the method of science? Okay. That is why Feyerabend repudiated the very idea of scientific method. Okay. He said that on what basis they are trying to look at the question of, or they are trying to answer the question, what is the method of science? Okay. Only by following consistency condition as well as correspondence condition. We have already discussed this, and for him this is nothing but law and order philosophy of science. Okay. That but he also said, but Feyerabend said, you see, science has made progress. Science can make progress not through logic and experiment alone, but also through, if you look at the history of science, it has evolved over a period of time and across space through dominant views which are historically conditioned. That is why science is historically conditioned. Even Kuhn in passing said this, that science must be examined in terms of its historical integrity. Okay? And then Feyerabend moved on to discuss various things about not having a particular method of science. Okay? Then if you look at, the way Feyerabend propagated an anarchistic method, people also say that this is a part of, not this is a part of, this also has led us to look at what kind of utopian pedagogy we can have. If you can look at Richard Day's works on utopian pedagogy and others, or deschooling by Ivan Illich. Okay. I think Feyerabend provides the framework of this, for this kind of characterization of schooling or education or pedagogy or science or training, life and so on. Okay. Now, if you look at this from ontological questions to the ontological questions about how technology, science and society have evolved, to the ethos of science, to the methods of science, and now, I mean ethos of science, I mean normative structure of science, normative institutional framework of science, to methods of science. And let us now discuss how science is inherently the way science has been designed and controlled is inherently unequal. Now, let us will discuss what kind of inequalities that which persist in science. We will discuss inequalities in science in terms of how Robert Merton delineated, discussed these things in the 1960s till almost for 3 decades, three and a half decades till he died in the very early part of the 21st century. In terms of the Matthew effect in science. I mean how the if you look at the slide here, you will find that how the reward and the communication systems of science are considered while dwelling upon the Matthew effect in science according to Robert King Merton. I have already discussed, we have already discussed that how Merton, though a functionalist, how he if you look at Mertonian functionalism, how he tried to deploy the method of functionalism to understand science, how science is inherently unequal, how science always tries to maintain hierarchy in a given social and political setup, economic setup, cultural setup, institutional setup, ideological setup, and so on. That is why the way Merton tried to look at the Matthew effect in science, what is the Matthew effect will come. I mean the Matthew effect in science, in this we are going to discuss the reward and communication systems of science. What is that Matthew effect? Very quickly we will try to cover this aspect, that the Matthew effect of accumulated advantage described in sociology is a phenomenon sometimes summarized by the adage that the rich get richer and the poor get poorer. The concept is applicable, I mean the concept of the Matthew effect is applicable to matters of fame or status, but may also be applied literally to cumulative advantage of economic capital. This term Matthew effect was coined by Merton in 1968. I mean the paper appeared in Science, one of the most prestigious journals in the world, and this term takes its name from the parable of the talents in the biblical Gospel of Matthew. And Merton credited his collaborator and his second wife Harriet Zuckerman as co-author of the concept of the Matthew effect. Now, we will see how Merton develops a conception of if you look at this psychosocial processes, how Merton develops a conception of which a conception of wage in which certain psychosocial processes affect the allocation of rewards to scientists for their contributions. That is an allocation which in turn affects the flows of ideas and findings through the communication networks of science. And such conception is based upon an analysis of the composite experience reported in Harriet Zuckerman's interviews with Nobel laureates in the United States of America, and upon data drawn from the diaries, letters, notebooks, scientific papers and biographies of other scientists. Okay. Let us begin with some general observations on the reward system in science, basing these on earlier theoretical formulations and empirical investigations. Some time ago, I mean, if you look at the 1940s, 30s, 40s, 50s also, 60s also, okay, it was noted that that graded rewards in the realm of science are distributed principally in the coin of recognition accorded research by fellow scientists. Okay? And this recognition, if you look at, is stratified. There is a process of social, economic, political, cultural stratification. Okay? This recognition is stratified for varying grades of scientific accomplishment as judged by the scientists peer groups, scientists peers. Both the self image and the public image of scientists are largely shaped by the communally validating testimony of significant others, okay, that they have variously lived up to the exacting institutional requirements of their roles. Okay. If you look at this, okay, a number of workers in empirical studies, okay, a number of workers in empirical studies have investigated various aspects of the reward system of science as thus conceived. Okay. Suppose for example, Glaser has found for example, that some degree of recognition is required to stabilize the careers of scientists. In a case study, Diana Crane, okay, used the quantity of publication apart from quality. Okay. That is what scholars of, experts on scientometrics also do today. Okay. That forget quality, only you look at only the number. Okay. That is why Crane used the quantity of publication apart from quality as a measure of scientific productivity, and found that highly productive scientists at a major university gained recognition more often than equally productive scientists as at a lesser university. Okay. That is why reward system in so far as educational institutions are concerned is also very important. Okay. Similarly, Hagstrom has developed and partly tested the hypothesis that material rewards in science function primarily to reinforce, okay, the operation of a reward system in which the primary award of recognition for scientific contributions is exchanged for access to scientific information. Suppose Storer has analyzed, okay, the ambivalence of the scientists' response to recognition as a case in which the norm of disinterestedness, ethos of science, the norm of disinterestedness, okay, institutional imperative of science that we have already discussed, disinterestedness operates to make scientists deny the value to them of influence and authority in science. Merton's collaborator, okay, Zuckerman and the Coles have found that scientists who receive recognition for research done early in their careers are more productive later on than those who do not. And the Coles have also found that at least in the case of contemporary American physics, the reward system operates largely in accordance with institutional values of the science, in as much as quality of research is more often and more substantially rewarded than mere quantity. Okay? In science, as in other institutional realms, a special problem in the workings of the reward system turns up when individuals, okay, I mean individual scientists or organization, institutions, okay, take on the job of gauging and suitably rewarding, okay, a lofty performance on behalf of a larger community. Okay. That is why we always say that in science you get a larger scientific community, but a few peers. Okay. Peer group is small, that okay, becomes small. In this way, okay, what we see that ultimate accolade in 20th century science, that is, I mean even in the 21st century, that is called the Nobel Prize, which is conferred on many intellectuals by the Swedish Academy, okay, is often assumed to mark off its recipients from all the other scientists of the time. Okay. Nobel laureates are placed on a higher pedestal because of this reward recognition, because of such unequal structures within science. Okay. How unequal, we will come to this point. Okay. Yet this assumption is at odds with the well known fact that a good number of scientists who have not received the prize and will not receive it have contributed as much to the advancement of science, okay, as some to the recipients or more. This can be described, okay, in the works of, I mean many, I mean you can look at different works. I mean those who have power, those who have authority, okay, they are rewarded more as compared to those who do not have power and authority. What holds, what Merton was trying to do here, that what holds the suppose for example French Academy of Sciences, okay, what holds for the French Academy for holds in varying degree for every other institution designed to identify and reward talent. Okay. And in part such circumstance results from errors of judgment. For Merton, in part this circumstance, okay, results from errors of judgment that lead to inclusion of the less talented at the expense of the more talented. Okay. And history serves as an appellate court ready to reverse the judgments of the lower courts, which are limited by the myopia of contemporaneity. Okay. In this sense, okay, we will come to the Matthew effect of the reward system. Reward system in science itself we are discussing now, and then the Matthew effect in the reward system, Matthew effect in the communication system, and the Matthew effect in the functions of redundancy, and how social and psychological basis of the Matthew effect and allocation of scientific resources. But before getting into this, okay, let us what we are doing when a particular generation is rich in achievements of a very high order, it follows from the rule of fixed numbers that some persons, some individuals, okay, whose accomplishments rank as high as those actually given the award will be excluded from this honorific ranks. Okay. Indeed, their accomplishments sometimes far outrank those which in a time of less creativity proved enough to qualify individuals for this high order of recognition.